data sensor as a singleton design pattern object, and it has a static reference to itself. You can ask the oracle for the static reference, and there you have your initial handler. Of course, every application can do this independently. So the first one maybe executes the constructor, and whoever comes first created the temperature data store object. The other one, the other applications after that only access the data store and use it just like a single. Okay, coming to the last part, just a little overview about what we have done in our Eclipse plugin. It is based on the JDT with a little bit modifications. We are providing a set of APIs when you create new projects. Currently we are supporting CLDC with some restrictions and some other classes to drive our specific hardware. The transcoding step is integrated into that Eclipse plugin, and you can just by a single click transcode an application or a single class file into a binary large object blob, and later on deploy that blob onto one or some nodes. The nodes can be discovered through the Eclipse plugin. There is the seamless integration of hardware nodes and nodes that are emulated on Linux machine. Of course, you can start new nodes emulated on Linux and test your application. And what I find very nifty about this plugin is that it supports in-system debugging of the Java applications. We are using a debug proxy design for that. That's an idea also borrowed from the Squawk VM, using the same technique. With the debug proxy, you can pass Java debug wire protocol messages to that proxy from every debugger you want to use, and the debug proxy translated into specific instructions for your hardware platform. So in this case, for our Ambicomp virtual machine. These debug proxy also serves the purpose of providing source code, line information, and everything else you have to get to do proper debugging. This line information, of course, would make blobs really large and is stripped from the class files when they are deployed onto the nodes. Okay, I already said that usage of hardware or emulated nodes is transparent, and you also get some views to monitor the nodes during work and have a look what they are doing. Okay, let me conclude my talk. What I present you is maybe new, easy development approach for networks of embedded systems. For that purpose, we created a modular hardware. You can use it for exploring such a system and rapid prototyping of projects based on such networks of embedded systems. We developed a very compact distributed virtual machine executed directly on the microcontrollers, which provides a single system illusion. So you don't have to care about communication explicitly and can do that in a more implicit way. And to achieve this, we introduced global accessible objects to pass around the information. Okay, thank you. Yes, please.
How does your system handle network partition with the global hash table?
As I mentioned before, the scalable source routing algorithm we use handles this partition, and it is still an open question how more higher layers, for example the application layer, can handle this partition. So what we are just doing right now is providing information about unreachable nodes to the application layer and let the application layer decide how to handle it. But you can get this information from a network partition. Okay?
What is your capabilities of your virtual machine? Do you have developed it from scratch, or
Yes.
you have?
Yes, we developed it from scratch, and it's just a simple but I think fast interpreter of the Java language. And we also reduced the number of bytecodes which is available to the virtual machine, because some bytecodes don't make sense in our kind of environment on the 8-bit microcontroller. So what you lose is support for example, class loaders. You don't have class loaders on our virtual machine.
But the capabilities, you feel the full Java.
Okay, it's a Java ME platform style.
Okay.
Yeah.
I have two questions. First question, did you make investigations how good your system is scaling when you go from 10 to 100 of your sandwich modules? And second question, of your total computing power of the cluster, how many percentage is spent of all the communication stuff, and how many percentage is left for doing the real stuff? So.
The first question, to answer the first question, we did heavy simulation experiments on the routing algorithm we developed, and this routing algorithm appeared to be scaling very, very well until a few networks of a few thousand nodes, with nodes having only memory available like in the scale of our sandwich modules. And the second question, until now we don't know how much network traffic is generated when applications are executed in a distributed way, but we are building techniques into the VM that uses heuristics to migrate objects and threads, if that is possible, between nodes in a way that network traffic is reduced. So this is an open research question, not only in this research project, but also, of course, was the question in the supercomputing distributed virtual machines.
You mentioned that in a regular distributed system you have to deal with discovery of